Hi, this is Mr. Manley. This is a video on evaluating inverse trig functions. I'm presuming some level of knowledge about how inverse trig functions work, and I will comment on some of that as we go through, but I'm not doing a lesson on inverse trig functions. I'm just working through some examples here. So we'll start off with this inverse cosecant rad2, and I am going to look for an angle on the unit circle that has cosecant is the, so I'm going to say cosecant is the reciprocal of sine, and sine is the y-coordinate on a unit circle, right? So for cosecant, I'm going to look for 1 over y. All right, so that's what I want to find here for this inverse cosecant of rad2. I want to find a 1 over y value on a unit circle that has a value of rad2. So if I look at the unit circle, that's not the best circle. Okay, that's a little better. And then on this circle, we're going to have these points here. I'm going to have this is at rad3 over 2, 1/2. This point is at rad2 over 2, rad2 over 2. Okay, so that's what I want to focus on, right? Because that has a rad2, and the one that I'm looking at here, that has a rad2 as well. So if I look at the remember I wanted the y-coordinate, the reciprocal of the y-coordinate. So if I take this y-coordinate here, and I look at the reciprocal of it, so that's going to be 2 over rad2, and then if I rationalize the denominator, that's going to be 2 rad2 over 2, which is rad2. So the reciprocal of the y-coordinate at this point here, right here. So the reciprocal of the y-coordinate there is rad2, and that's what I'm looking for. So that's happening at this position here, which is pi over 4, right? So that's what the inverse cosecant of rad2 is. It's pi over 4. And we're only looking for the angle that is between negative pi over 2 and pi over 2. And again, I'm not giving a full lesson on inverse trig functions, but if you have received a lesson or looked in a book about that, you'll understand what I'm saying, that we need to be between negative pi over 2 and pi over 2 here. Okay, so let's go to this cosine, inverse cosine of rad2 over 2. So I want the x-coordinate on the unit circle, and for this one, I want to be between 0 and pi when I'm talking about cosine. So I want the x-coordinate of rad2 over 2, and that'll be up here as well. It's kind of same position. Just got to erase that. Okay, so that's going to be here at rad2 over 2, which is at pi over 4. So the inverse cosine of rad2 over 2 is also pi over 4. And just to stop and think about this and maybe slow down for you. So the reason that I know, or a way to check that the inverse cosine of rad2 over 2 is pi over 4 is that's going to be true if it's also true that does the cosine of pi over 4 equal rad 2 over 2? And when I look at pi over 4 and I look at the x coordinate, yes, it does. So we've got the correct value here. Okay, for the cotangent, I'm looking for x over y, right? So let me just write this out. I didn't say I was going to do the instruction here, but just want to help you out a little bit and say, so what I'm doing here, I'm going to evaluate this. I'm going to answer, what is the angle with cotangent value rad 3 over 3. And then within that state, so that's what this equals. This is equal to whatever the answer to this question is. Okay, that's what this notation means. So let's look at that statement a little bit and just say a couple things. One is the angle has to be between negative pi over 2 and pi over 2. Otherwise, we're going to have infinite possibilities, right? Which is okay in some contexts, but in this case, we want one unambiguous solution. So it's going to be between negative pi over 2 and pi over 2. And then this other part here, this cotangent value, what's a cotangent value? On a unit circle, the cotangent value is x over y. So rereading this statement, I say, what is the angle between negative pi over 2 and pi over 2 with cotangent value, that is x over y, of rad 3 over 3. So let's look up here at our circle. And we are going to look for the x over the y. So if I start here at the first coordinates that I have, which are going to be rad 3 over 2, 1/2, the x over the y is going to be rad 3. Okay? So you should be able to see that. But so if I take this and I do the x over the y, that's equal to rad 3. Well, reading my statement down here, I need the x over the y to be rad 3 over 3. So that's not it. Okay, so we'll look at the next coordinate that we have. Go back here. Okay, looking at the next coordinate that we have, well, it's not going to be that, right? So the next coordinate is rad 2 over 2, rad 2 over 2. For one thing, I can just look at that and see, well, x over y is 1. For another thing, I've got a rad 2 and I need rad 3. So it's not going to be that point at all. And then I get to the next point, which has, or the next coordinates that have a rad 3 in them again, right? So that goes 1/2 rad 3 over 2. And then when I do the x over y for that, so I take this and I look at the x over the y, it's going to be 1/2 over rad 3 over 2, which is 1 over rad 3, which is rad 3 over 3, which is what I'm looking for. And where did that happen? That happened here at pi over 3, right there. And that's at pi over 3. So that's what we got for this. Okay? All right, now let's go to next page here. Okay, here, now on this we're gonna work from the inside out. So I'm gonna start off with this inverse tangent. Now let's look at the question that we need to answer to evaluate that. What angle from between negative pi over 2 and pi over 2 has tangent value, that's y over x, of rad 15 over 8? Well, we don't know. We don't have rad 15 over 8 on our unit circle. But what can we say here? I could say, well, all right, well, I'm going to say that rad 15 is y. I'm going to say that x is 8. So I'm talking in terms of the x, y, r definition of trigonometry. And then I could also find r here, because x squared plus y squared is equal to r squared. Now, I don't need it, but I do want to come back to it. But for right now, I've got y and x. So I'm just going to talk through this and say that here I've got an angle, tangent, inverse tangent of rad 15 or 8 is some angle that has a y value of rad 15 and x value of 8. Well, what's the cotangent of that angle? The cotangent of this angle? Well, the cotangent of any angle is x over y. So this is actually 8 over rad 15. That's x over y. Okay? Now let's go back here, because I want to use this x squared plus y squared equals r squared. So I'm going to go back here to this cotangent and say, how about we say we're looking for the, I don't know, let's look for the cosecant. Okay? So if I'm looking for the cosecant, let's think about that. I know that sine of theta is y over r, so that means that cosecant of theta is r over y, because cosecant is the reciprocal of sine. Now look up here. I know y. Y is rad 15. Can you see that? So what do I need? I need r. I don't have r right now. I have x and y, but I can find r easily enough. So I can go x is 15, rad 15. Y is 8. We'll square that. Equals r squared. So that's 15 plus 64 equal to r squared. And that's 79. I just skipped it. Rad 79 equals r. So now I've got r, and I can just plug that in right up there. 79. 79. So rad 79 over rad 15. Okay. Now let's just make a little bit more sense of this for you. Let's look at the numbers, because I know students like to see numbers, like to use numbers to make sense of things. So if I take a calculator, I should say not just look at the numbers, but look at a calculator, use a calculator, because students like to do that, right? So I'm going to take this, and I'm going to plug that into a calculator. Okay, so when I plug that into a calculator, I get 25.8 degrees. And I put my calculator in degree mode, because there's anything that students like more than using a calculator, it's working with degrees instead of radians. And then I've just got this other calculator entry here, right? Cosecant 25.8. So let me do that entry. And that entry is gives me 2.98. Okay? Now let's go up here. Let's go back up to this. Rad 79 divided by rad 15, and I get 2.29, and actually 5, but close enough, right? So we see what we've done when we work without a calculator, and then we see what it means with the angle and then the trig value of the angle. And that's all we're doing. Okay, let's look at one more thing here. So here we don't have any numbers. And there's a couple of ways that we could look at this. Now remember that whenever I have this inverse trig of something, all of this taken together is an angle. Now let's say that I could refer to that angle like this. I could say, okay, there's some angle. This angle, the angle is theta, right? So there's some angle theta. Inverse tangent of x is some angle theta. And we want to eventually know what's the secant value of that angle. So there's an angle, and let's go back to my statement I keep saying is what angle has tangent value, and in this case it's x. What angle has tangent value x? Well, and then what I did the angle has to be between negative pi over 2 and pi over 2. And then what else did I do? I said the tangent value, that means y over x. All right, so what angle has a y over x of x? A little confusing here maybe because these are two different x's. They're not, they look the same, but they're referring to something different. So this is the y over x of the xy coordinates on a unit circle, right? Or any trig circle. And this x is whatever value we're taking the tangent of. So, so y over x, also known as opposite over adjacent from our SOHCAHTOA days, right? So, difficult to follow, I understand. But see if you can understand that what angle has a tangent value of x. So the angle is this theta that we're talking about. And if I put that theta into a triangle, into a right triangle, if its tangent value is x, right? So its tangent value is x, that means its opposite over its hypotenuse is x. Its opposite over its hypotenuse is x. Well, what would the hypotenuse need to be here for the opposite of the hypotenuse to be equal to x? It would need to be 1. So that's 1. And then I just need, well, back it up, sorry. Not opposite, it's opposite over adjacent, right? Not hypotenuse. So this 1 I need here, right? So there's opposite over adjacent. Okay. So I've got opposite over adjacent of x, which is x over 1. And then I can find this hypotenuse here just by the Pythagorean theorem, right? So I could go, and I'm going to call this r. So I could say x squared plus, or a squared plus b squared, which is x squared plus 1 squared, is equal to c squared, which is r in this case. And then r is this. So now I've got r. And what is, so what do I want? The secant, I want the secant of this angle. Well, secant is what? The reciprocal of cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And if that's too much of a mouthful for you to follow, you can rewind and listen to it again. So secant is the reciprocal of cosine, or I'll say it again. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse, which in this case is r, or x, rad x squared plus 1, over adjacent, which is 1. And that's where we end up. Okay? Biggest thing is, to keep coming back to in inverse trigonometry, is this statement, and understanding that this is an angle. The inverse tangent of something, all of that taken together. When I evaluate that, it evaluates and comes out as an angle.